Hello everyone! How's everyone doing today? Alrighty, so today we're gonna try something different. We're gonna try to complete the Advent of Code challenges, at least the first and second one. But instead of using normal programming language, we're gonna try to do it in SurrealDB, using the Surreal query language. I believe it's possible. I haven't even thought about how I'm gonna attempt it, but I'm sure we're gonna figure it out. So let's take a look at our tools, okay? Because this is, of course, our challenges, but how we're going to complete that. I made a little repository where we have everything that we need. Let's go to 2025 SurrealDB. And this is where we're gonna add our files. So we're gonna add day one. So everything will be in the repository that's linked in the description if somebody wants to, look at the code or whatnot. We're gonna add that code here. But I think the actual coding we'll do in the Surrealist, okay? And we're gonna be able to create a new fresh sandbox, and this is where we're gonna do it, because we can write our code here, run it immediately, and it's the goal I want to put on this challenge is to make it where everything works on Sandbox. We don't need any extra features. We don't need to enable any JavaScript shenanigans. Let's try to do everything just purely within the query language. And also I would like to make it that whenever our query completes, the result is all we care about. As in, we're not defining any database tables, nothing like that. Just we send a query, we get an answer, and nothing happens to the database. That's what I would like to accomplish. We'll see if we'll be able to, or if we'll need to do some cleanups or whatnot. We'll see, but we're gonna do that, and I think we can do something like view about. Yeah, we're gonna use the Surreal's version 368. Okay, so we can probably just note it here. Completed using Surrealist 3. What was it? 368. 68 in a sandbox. Okay, this will be it. So that's the goal. Let's take a look at our first challenge. What do we even need to do? Okay, so this is our Advent of Code. Starting this year, there will be 12 days of puzzles each December. Wasn't it like more in other year? What the hell does that do? Nothing. It just, is it like regarding code or something? Depot. I don't know. Never mind. Let's take a look at the first one. So we've got a story and a puzzle, and it's all one. All right, let's get going. Day one, secret entrance. The elves have good news and bad news. The good news is that they've discovered project management. Oh no. This has given them the tools they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations need to be finished soon so that the other critical tasks can start on time. The bad news is that they've realized they have a different emergency. According to their resource planning, none of them have any time left to decorate the North Pole. Okay. Oh, that thing is so annoying. Let's just lock it. To save Christmas, the elves need to finish decorating the North Pole by December 12th. Okay, I guess that's the deadline that we get. That there's only 12 puzzles this year. Collect stars by solving puzzles. 2 puzzles will be made available on each day. Oh, okay, so there will be 24 puzzles. All right. The second puzzle is unlocked when you complete the first. Wait, today's December 2nd. Interesting. Each puzzle grants 1 star. Good luck. You arrive at the secret entrance to the North Pole base, ready to start decorating. Unfortunately, the password seems to have been changed, so you can't get in. A document taped to the wall helpfully explains. Due to new security protocols, the password is locked in the safe below. Please see the attached document for the new combination. The safe has a dial with only an arrow on it. Around the dial are the numbers 0 through 99 in order. As you turn the dial, it makes a small click noise as it reaches each number. The attached document, your puzzle input, contains a sequence of rotations, 1 per line, which tell you how to open the safe. A rotation starts with an L or R, which indicates whether the rotation should be to the left, towards the lower number, or to the right, towards higher numbers. Then the rotation has a distance value, which indicates how many clicks the dial should be rotated in that direction. So, if the dial were pointing at 11, a rotation of R8 would cause the dial to point at 19. After that, a rotation of L19 would cause it to point at 0. Yeah. Because the dial is a circle, turning the dial left from 0, 1 click makes it point at 99. Similarly, turning the dial right from 99, 1 click makes it point at 0. So if the dial were pointing at 5, a rotation of L10 would cause it to point at 95. All right. After that, a rotation of R5 could cause it to point at 0. All right. The dial starts by pointing at 50. Okay, so this is important. We start at 50. You could follow the instructions, but your recent required official North Pole secret entrance security training seminar taught you that the safe is actually a decoy. The actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. For example, suppose the attached document contained the following rotations. Bam. Following these rotations would cause the dial to move as follows. 50, 82, yeah, and then it points at 0. So that's 1. Continues, another point at 0, and bam, bam, bam. Because the dial points at 0 a total of 3 times during this process, the password in this example is 3. Analyze the rotations on your attached document. What's the actual password to open the door? To play, please identify yourself via one of these services. Let's do this. I don't know if I'm logged in here. Looks like I am. Okay, so get your puzzle input. So this will be our input that we're going to put into SurrealDB. I think I already know that this will be relatively easy. Okay, this is a lot of input. So let's grab it all. Ooh, that is a lot of scrolling. We copy and okay, so let's do let input is, and how do we do multi-line things in SurrealDB? I forgot. So SurrealDB.com, let's go to resources, SurrealDB docs, and let's see if we can actually go to SurrealQL. Oh, I like it that it's a nice switch now on top. Awesome. Operators? I don't think so. Let's go into, we have literals, which will be declaration of parameter. No, we just need to go to strings and maybe it'll be explained. Okay, strings can also include line breaks, so we can just do that. Okay. So we do this and paste it in. And That is absolutely horrible. Because, oh my goodness, we have a lot of those. I mean, I don't want to deal with a query that's like this. Let's just try to create a record that will hold it, all right? We're gonna make it create input and raw. Okay, that's what we're gonna call it. Table input, element, the record ID will be raw, and set content is all this, and we're just gonna keep it a string. We ended with this, right? Run query. There we go. We've got our contents. So in our Explorer, we have input with our one single element, and it just has that. Awesome. We still have it, or did I lose it? Of course I lost it. I need to remember not to ever, like when you're in the sandbox, never ever click back to overview. It's gonna just wipe sandbox for some reason. It's like extremely annoying. Not sure why it does it, but oh well. Now we can set variables here too. Okay, all right, I see, but I want to do that. There we go. It's set. So let me just copy all this and oops, and we're gonna switch to our thingy and day one. Let's do query. I mean, this will be, let's just paste it. Yeah. So this is our first query. All right, we have this whole thing and we're gonna continue from here. So now that we have it in the database, let's get rid of it and think about it. So basically, we need to start at 50 and they basically get the list of the numbers that we got, split into single lines. Then we will need to extract the first character of each line to know if we're going left or right, and then call an appropriate, somehow modify the current value that we have here. Okay, so there are a few problems here. The first one is that in Surreal query language, we don't have the ability to create a variable and then set in a new value afterwards. It's just once you set something, it's just read only. So we have either an option of dealing with something like, I don't know if array could be even modified. Probably not to a great extent. So we could either make it in some kind of recursive manner, which I don't think is a good idea. We can just keep writing to a record, right? Because we can do create record or like set value or something, and that should be fine. So I can see it as the first thing we need to somehow set the initial value to 50. Then we're gonna do split everything into lines, process each line, and update the value. Okay, and somewhere in there will be if 0, increase password. And at the end, will be basically return password. This will be our last statement. So we have set initial value to 50. We'll also have set initial password to 0. So what we can do is make kind of at least the ID of the current value or whatever dial value and the password as some kind of constant. So we can make something simple. you know what? Let me think about it, because we called it input. I think it'll be, this creates a table. Let's kind of simplify it even more. If we have this thing here, we could name it something like, maybe something simpler, like temp. That'll be our table temp. We can just wipe the whole table and call it a day. Input. That will be the thing that we're doing. All right. Let me just copy it all, and I'm just going to run a new query. This will be rename set input. Okay. And we can basically quickly go here, straight up delete this table so we start from scratch. Or we can just click this button, right? Reset. There we go. So set this. We have our new content in a proper temp table. We have the input record. So therefore, in here, we can basically say that our dial ID will be temp dial. There we go. And we also do let password ID will be this. Okay. And therefore, we can set the initial values. So we can do, we could basically, because we'll be setting this record, so we could either assume that we already have no data, or we could go the safe way and basically update it or insert it. So let's go here. And we should have something like, is there upsert? Yeah, the upsert statement can be used to insert records into the database or to update them if they exist. There we go. So we have upsert person, set name. There we go. So that's all we need to do. And we can use normal set. There we go. So we'll basically do upsert. The dial ID. And we do set value. We want the value. Let's just, sure. I don't, yeah. Value on its own is not a keyword. Only if we have the $sign in front of it, that's when it's problematic. So we start at an integer 50. All right. So we set our initial value. We can also copy it and do the same with the password ID, which starts at 0. Okay. There we go. I know that everything could be kind of as a single record, but this way will be quick to look it up and whatnot. All right, so we set the initial values. Then we need to split everything into lines. Before we do that, instead of returning the password, the way we're going to return it is return. I'm going to do select. What was it? Select value. And this will be the value from only pass ID. And that should give us, I think we can just do that, right? Return the password. We should get just 0. So our last query returns 0. There we go. While our temp, when we refresh, has our dial, has our password, everything. Dial has value 50. Password has value 0. Beautiful. Not sure why they don't show up here. Oh, right, because this is content, this is value. Sure, good enough. Oh, and I just reset it. Oh, how many times I'm going to do it? But hey, we just input, let's do value. Everything is going to be a value, okay? Run this query. There we go. We just quickly modify it here. And value. There we go. All right. And okay, so this is proven to work. Now split everything into lines. So something tells me SurrealDB will have some fun things in functions. Database functions, right? And there should be string functions. Do we have some like split, capitalize, concatenate, contains, and with, ends with join, length, blah, 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 blah. Slice, extracts, and returns section. Okay. Split. Divides a string into an ordered list of substrings. There we go. The following example shows this function and its output when used in a return statement. Split, this is a list by comma space. Okay. So I'm assuming we can do simply something like let instructions is, and now we basically need to extract our value, right? So let's do this. Select. We're gonna do the same thing here, or we're gonna do it in a fun way where everything is just one thing. Select value from the temp. What is it? Input. Okay. We select this. Then we're gonna do split, and we should be able to just grab, because we already provided this. So what do we split it with? In our case, it's just the new line symbol. So we should be able to do new line there. I guess we can do this. It doesn't really matter. And I hope I can do this because this is fancy. I would like to return this right now. Return. Sure, return instructions. So I'm going to do just run this part and see what happens. Okay, look at that. We've got all the strings. Perfect. That's exactly what we wanted. So now we can go a step further and do something more fun. So instead of saving those instructions as those little strings, we can actually do something like in JavaScript. So we should be able to now, instead of focusing on string functions, we can look into array functions, and we should have something like a map. There we go, map. So 1, 2, 3 map, and there we go. This is where we can do some magic. So we're gonna do straight up map. And we take, this will be, we just need to name each element that we're mapping over. So it'll be instruction, whatever, or let's just call it line. All right, so this is our line. And here we start our block of code, right? We don't have to have it, but we can have. And in our case, you know, we can create variables there, do our if statements. So this is fun. So now we basically need to take this little line and basically turn it into an object where maybe not even worry about left, right. It could be just either positive or negative number, right? So let's look at the functions and strings, because something tells me we have something like starts with or whatnot. Starts with, there we go. Starts with, okay, so starts with. If this starts with sum, true or false. Perfect. So we can do some if statements. And a second ago, we saw some here. If this, else that. Beautiful. So we can do if. Do we need to put in parentheses? No. If line dot starts with, and we say left, Well, just for consistency, we're going to do this. Let's also make it capital F, because we already started that then. And I believe we can just do... Oh, we actually don't need then. I think that was the old syntax. So if it starts with left, we do return statement here? Or what do we do here? Oh. Wait a moment. In map... Okay, in map we don't do return statements, right? Yeah, we don't do return statements in here. We just kind of create an object. So sure, we're gonna create an object. Oh no, we can just a number, right? So it'll be... Oh, now we need to parse it into... Now we need to parse it into a number, that's right. So I know we can convert it, but I don't think it's gonna work in here, but we can try. Let's just see if our string has something like parsing, or more like parse functions. There we go. Domain host. No. Is IPv something, whatnot. Okay, so we don't have 2 or whatnot. Let me just see if we have something like integer or number. This is purely math. So we can just try to probably extract a substring. We have substring. I saw something like that. With S, slice. String slice function extracts and returns a section of a string. So from this to that and whatnot, it will be test. So we need to have exact numbers. Looks like we can't have just negative or plus or minus or whatnot. So, okay. So we'll need to use the slice in some fancy way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we have 10 characters. So this starts from 0. So from here, 1, 2, 3, 4, 10 is here. And from that point, it will be 4 characters. Okay, so in our case, it will be 1 to whatever the length is minus 1. Okay, we can do that. So we should do it before we even do anything with it. So let's do let, and then it will be maybe not value, but I don't know. Parsed number is, we're gonna take our line, we're gonna do slice, right? And we're gonna say it's after the first character. And now we basically need to get line.length minus 1. And this should give us the actual value for the number as a string. And I recall we had this fancy thing for casting. Is it casting? In SurrealDB type system, values can be converted to other values efficiently. This is useful if input is specified in a query, which must be a certain type, or user may have provided a parameter with an incorrect type. So all we need to do is something like integer. There we go. So we can just take a string, slap on integer in front of it, and that should be it. So we're going to do integer and wrap it in parentheses. So that's a single thing. And that should be our parse number. So basically, if it starts with L, which is left, it's negative, we're decreasing the numbers, we're gonna return our parsed number times -1. Okay? And else parsed number. That's the only thing that we're gonna return. Do I need... Yeah, I need those in here, I believe. There we go. And after our if else, let's just verify that I'm doing if else correctly. Okay, the modern syntax: if condition, expression, else, expression, right? And we have those inside, so that's good. And it looks like we don't have anything after the if statement itself. If statement, oh no, look at that. It is here. Because I guess it's a separate query or something. So yeah, let's just slap on a semicolon here, and it should be something. So that's the instructions, right? We are basically mapping them all into those numbers. So let's see that if we still get strings or this actually works. Run. Uh-oh, we got a bunch of nonce. Why? Why do we get that? What if I'm going to remove our cast? Will that help? Or is it still nothing? Or am I just not scrolling down enough? No, it's all that, yeah. So let's try it again. Run. Can perform multiplication with 47 and -1. Okay, so looks like 47. Wasn't that the first? The first thing is 47. Yeah, left 47. So that worked. Kind of. Yeah, it worked. It tried to make it -47. So somehow, you know, this was still working here, right? This worked. We got all that stuff. We're just not properly setting it. What is going on here? I'll try to remove that semicolon because I'm confused about the rules here. I know that version 3.0 of SurrealDB will have improved ways of kind of passing errors and inspecting things. So let's run the selection and we still have the same, right? We map them, we just don't have the appropriate values returned. If I'm gonna slap on return, it's probably just gonna return. So that's not an option. Let's look at the map again, the documentation for map. Database functions, array functions, and there'll be map in here. There we go. So this is the definition. So we can do map this into that. Great. A longer operation that uses curly brackets. So we have map this value and we open up. Number is this. There you go. We just mapped string to a number. That's great. Let is even. So if this, then that, and that, and that. Oh, and then it returns this value. So maybe what we can actually do is, instead of just having this if else statement here, let's do let result is this, okay? And then we're just gonna do result, maybe. Let's see what happens. Run, and there we go. We've got our numbers running. Beautiful. Left and right. So now that we have this whole thing, we'll be able to simply go over each one in a loop and adjust our dial. And every loop, we just need to check if it's 0. And if yes, we're just gonna adjust the password value. And that's pretty much it. Okay. So let's do it this way. We've got our instructions. We don't need this thing anymore. So, well, extract left/right integers. So minus/plus from the input lines. Okay, so that was it. Now we will need to do and whatever adjust dial in a loop. So we have a for loop. Okay. Gosh, this is pretty simple. Okay, so our syntax is, what the hell is railroad diagram? Ooh, okay. I need to learn about those railroad diagrams. What is this about? What is it about? But okay, exam. Can we like click on stuff? Nah. All right, so for whatever iterating, whatever each element will be like inside our list, in our case, we can do whatever we want. Great. So this will be extremely simple. So we do for, and this will be instruction. Okay. In instructions, because that's what we call them, instructions. And we just have our curly braces, right? Yeah, and we just do something inside there. The for loop itself can't return anything like outside of it, but we can just use records as something we save to. So in our case, we'll basically need to do a few things. So we'll need to, I know that normally one could, plus equals or whatever to adjust the value of the record in one go. But in our case, we want to read it as in, read dial. Then we're going to do adjust or like calculate new value. Then in case it's negative or over 99 will be a wrap value. So we need to adjust it so it's still within a 0 to 99 thing. Is it 0? Update the password. And then it'll be update dial. And this will be our iteration. That's all we need to do. So to read the dial, we can do something. Didn't we already do that somewhere here? We can just copy this for now. So let's say let dial is this. And instead of input, it will be temp dial. And we extract the value out of it. There we go. That's how we read the dial. The new value will be let new value is the value of the dial plus the instruction, because it'll be plus or minus value. Then we need to wrap. So it'll be here we basically need to do let wrapped value. And we can use our if statement again to kind of decide. So if the new value is less than 0, then we're gonna do something simple. We're gonna adjust it, right? Now I'm thinking, is it possible for the value to be more than like 99 steps, like 200? Look at that, 180. So it can wrap twice. 718, it can do multiple circles. So we're going to end up with something. So we can't just have if it's lower to this, if it's larger to that. We would need to have like entire loop in here to kind of adjust it on its own. So we can do that. Or just do some math. Yeah, we can do math. Because we can see, it's less than 0. By how much? How many 100s can we fit in there? And that's where we can get it from. So if the new value, of course if the new value is less than 0, then we need to add something. So how much less than 0 it is? We just have the value. So let's do let adjustment value is how do divisions work here? You have operators, right? Divide by value. Do we have info about this? This would be 10, but what about integers? Let's try it. Return, no, 10 divided by 2, right? If we're gonna run this, this thing, it's fine, 5, that's great. If we do by 3, we got 3, okay. By 4, should be 2. Okay, so this is operating on integers. Perfect, that's exactly what we need. So, let's say revolutions, how many revolutions it passed. Whatever extra revolutions. It will be the new value tab, because it's negative, so it will be times -1, and we're gonna do divide by 100. So that should tell us how many times we need to wrap it. Okay, great. So in case we had something like, so let's say that we had a value of -12, right? That turns it into 12, and divided by 100 will be 0. So we have no like extra revolutions. So we just need to add 1 extra revolution. So we're gonna wrap it again and do basically +1. So now the wrapped value will be a new value plus revolutions times 100, and that's how we adjust it. Great. So this is the value here if it's less, and if it's larger, it's gonna be pretty much the same. I guess it's just without the plus or minus. Let's see. Else, if new value is larger than 99, okay, it's larger than 99. Again, we're gonna calculate revolution and adjust the value. So revolutions will be, we don't need to adjust because it's already positive, okay? So, and let's say our value is 12. We divided by 100, so we have 0 revolutions. So we need to kind of, we'll be subtracting. So again, we just leave the +1 because it's already above what we're supposed to do. Oh, wait, just wait. It doesn't work that way. Because this is not 12, this would already be 112. Let's say it's even not just 99, it's just 100. If we're going to divide it here, it will be 1. So we're going to already put it 1 by 1 revolution back, and that's going to end up at 0, which is within the range. So we do literally just that. Okay, and instead of plus, it'll be minus. And this should basically calculate the wrapped value. I don't know if I'm explaining things correctly. If you have questions or suggestions, feel free to just share it in chat, or even after the video, just post in the comments. All right, so this is great. This is our new wrap value. what we can do is maybe we can first update the dial so that we have the new value set, and then if check for 0. So what we're gonna do is update our dial. We're gonna do it exactly the same way. Although we can just do update, right? What was it? Update? Update, there we go. Update was content. No, update person set, there we go. So we're gonna do update this. Oh, this didn't add, there we go. Update dial ID, set value to be the wrapped value, there we go. Okay. And that's for the instructions. There we go. And therefore, is it 0? Yeah, so now we're just basically check if it's 0. If it's 0, increase password. So we should be able to do if wrap value is 0. That was just single equals, right? Oh no, we are comparing here. Check whether two values are exact. If are the same type, but we have normal, right? Yeah, we don't need an exact. We just check if it's 0. Yes, if it's 0, then we're gonna basically do update pass ID set value, and I believe we can do plus equals 1. And this way we don't even have to read the value first to check it. Just increase it by 1, and that's it. Do we have like increase or something? Increment? No. Okay. But inside the update, we should have something. Merge, is a timeout. I'll recall something. There we go. Plus equals, that will add to the list or to a string or whatever. Great. Hopefully it's gonna work. And that's it. So yeah, that's our loop. We go through all the instructions. And at the end, return a password. There we go. We close our for loop here with another semicolon. And this should literally be the answer. So for our thing, I mean, I just don't need to select them. Run the query. We have all this fun stuff. Cannot perform addition with none and 26. That's the query. Oh, we are getting something bad. Query 6. So it'll be 1, 2, 3, 4. This is 5. And it returned nothing, which is great. And this is 6. And cannot perform addition with none and 26. So let's look at our values here. Where would we end up with this thing? We start at 50. This will be all the way down to 3. Okay. What was it? Like this. There we go. I'll just create a new file. So we start with 50. Then we go to and here to basically 3 because we move 47 into to the left. Then we do to the right, it will be 26, so it'll be 29. Then we're gonna do to the left 18, which will be, wait a moment, 11. And then we're gonna go to the right 18, so we get 29. Where do we get 27, or what is it complaining about? 26. And then to the right will be 26 again. How many iterations it went through? Unless it's because we have the number right and left passed, the right just figured not really. So let's look at it. Revenue value, wrap value. So basically, if it's less than 0, that wasn't the case. And the new value was still positive. If it's larger than this, no. Oh, we don't have other statement. If it's exact, then we're, I don't think we actually need this here. We can just, otherwise it's just the new value. There we go. Oh, so dumb. Wrong query. Nope, it needs it. Okay, sure. I can live with that. Okay. 1013. Now the question is it actually right? We need to write our own data to kind of learn it. So let's get, because, you know, we either submit it and learn that way, or we run our own data. So let's say that we start at 50, right? So maybe we want to, again, do L47 to bring it to 3. Then we're gonna do our, I don't know, 50 to bring it to 53. And then if we have 53, let's do L53 to bring it to 0. That should be number 1 already, our first 0. Then we're gonna do again left 10 to make it to -10, which should make it to 90, okay? At L90, that should be another 0, so that should be our second one. Then we're gonna do left, and let's do 2000. That should do many rotations, but that should be another 0. So we have 1, 2, 3 zeros. Then we're gonna go to the right to 99. That should be 99. Right 1, that should be another 0, so that should be our fourth. And let's add 5 more. Let's do freaking 20,000, which should again end out at 5. And that should be it. Let's say that we start with this kind of list. Okay? So let's just select it, copy it. Let's just make sure. 1, right, 1, 2, 3, 4. The answer should be 4. So let's set the input. Let's just do rename set fake input. All right, and I'm just gonna paste it here. This will be just that, and we can copy it from here. Copy and paste. So let's actually wipe everything. We can set our fake input. There we go. And our new query should just straight up give us number 4. Ooh, we went to number 3. Why is that? Did I miss anything? Maybe I just messed up. So this will be, you know, it starts at 50. So after this will be 3, right? After this, it'll be 50 to the right, so it'll be 53. After this will be less 53, so it'll be 0. Left 10 should be -10. So we're going to add 100, which will be 90. Okay. But this is the 0. That's also, we just add that, hey, this is 1. We have 90. We do left 90, so we do another 0. So this should be 2. We add 2000, which will turn it into 2000, which should basically keep rotating to the right until it reaches 0. So that should be 3. Then we have to the right 99, so it'll be 99. Then we have add one more, which will be 100, which should bring it to 0. So that's our 4. And then we should have 5. And after this is multiples of 100, so it will be again 5. So why do we get 3 and not 4? Where are we making a mistake? Let's make a little adjustment. And let's create a record that will hold all the consecutive calculated values, okay? We can use something like that for debugging. So we're gonna do it will be debug ID, temp, debug, okay? And what we're gonna do here, we have our instructions, that's great. Read dial. So we have a for loop, right? We read our dial, we calculate the new value, and wrap it. And this is basically to update our thing. So we can also do update debug ID set dial values plus equals the wrapped value. Okay. And I also want to record other things. So maybe let's just call it values. And we insert another entire object in there where we can say we have, let's say, wrap value will be this, okay? But we also have the new value, a wrap value, and maybe we actually get the password value out of this somehow. So we're gonna add it at the end. So it'll be the pass value. Okay. We're gonna do it this way. And this should be, this way we'll be able to kind of keep record of those. Let's even do instruction. Okay. So let's do let pass value will be, again, we can just get it the same way we did here. It's just we extracted from the dial. And not temp dial, this was dial ID. There we go. This will be the pass ID. Oops. So this little thing will be our debug. So we extract the new updated, if we updated password value. And we basically, in our debug ID, we add to the value. So we need to set up the initial values set. So just like we did those, we need to do the debug ID. And we say that values will be an array where we have already the first object, which will just have dial value. And that will be 50. Okay, because that's what we're starting at. Great. And with that, we'll be able to just update it. So I should be able to just, first of all, let me just copy and kind of include it at the end here so that we don't lose it. Okay, this will be our everything. Awesome. So when we run it, we have all this stuff and we return 3. But now in our Explorer, we should go to temp and have our debug and have all the instructions that happen. So we start at 50, -47, right? That's great. Let me just move it maybe here so we can see it side by side. So start at 50. Okay. left 47, negative. New value is 3, wrap value is 3, awesome, password is 0. So that should turn into right 50. Okay, new value is 53, beautiful. Then we do negative 53. Okay, new value is 0, password upgraded once, up, awesome. Great so far. Left 10 should do it to 90, right? Because we had 0, negative 10, new value is negative 10, wrapped to 90, beautiful. So we go again left 90, which should bring it to 0, and we increase the password value, beautiful. And oh, there we go. Here's our problem. Ha. So now when we try to move to 1000 times, the new value is negative 2000. Beautiful. But wrapped value, it wrapped it the wrong way. Okay. And that basically ended up thinking it's 100. And going to the right fixed it, right? Because we added 99. 199, then it wrapped it and whatnot. So we have that problem. And with the right one, I'm just checking because these are all, I assume, is normal. But we had also a gigantic value to the right, which turned it from 2000 to, or whatever, from 5 to 20,005. But it wrapped it probably to just 5. So wrapping to the right, or from the extreme right works, but wrapping from the extreme left doesn't. Okay. So let's move it back here and go back to our query. So let's again look at our wrapping to the left. Okay. Let's use our example of we got negative 2000, right? So when we calculate revolutions, we get a new value, which is negative 2000. Times negative 1 will turn it into just 2000. We divide it by 100. So that will be basically 20. We increase it by 1, so it'll be 21. And then we take the value, which was the negative 2000 plus, and we have 21 times 100. Oh, so the plus 1 doesn't even need to be there, right? Which will result in negative 2000 plus 2100, which results in 100. And that's the problem. So that's the problem. We just have that extra plus 1 that I think we don't need. Let's just verify for something a little bit smaller. All right. Because what if we have something like the starting value is, I don't know, negative 12, right? If we're gonna follow calculated revolutions, will be times negative 1, so it'll be 12 divided by 100, which will be 0. So we do negative 12 plus 0 times 100, which will yield still be at negative 12. Okay. So our situation has a problem only in cases where at the end we end up with different value. So why is it happening? I mean, the easiest solution would be to, okay, this is our new value, right? The revolutions. Instead of just doing that, if it's 100, just decreases by 100 and that's it. Let's just do this very dumb thing, because we'll never have a situation where it's over 100 at the end. So let's say adjusted value. Okay, will be this thing. And now, okay, So now we're gonna do let final value, whatever. I'm just making up weird stuff. So if adjusted value is 100, then we're gonna return adjusted value minus, oh, we're just gonna return 0, okay? Else return the adjusted value. It's not pretty at all. It's absolutely disgusting. And then we just do final value. But it should work. Run a query and we should get 4. There we go. And now in our debug, I don't know. Oh, there we go. So it went correctly. 53, 0. And we increased. 90, again 0, good. This wrap back to 0, good. 99, 1, we're up to 0, perfect. 5 and 5. Okay. I think it's gonna work. We tested wrapping in both sides, everything. So we can just straight up wipe it. We've got nothing. In our query, we can set the input. So we run it. We got everything. And this new query. Run it. It's thinking for a moment because the database is not supposed to do all that stuff. Okay, this is taking a long time. What the hell? Last time it went super fast. Oh, because we're just adding all this random debugging stuff. But that shouldn't be that slow either. It just hangs. Oh, we got a result. 1150. Let's copy it and let's just try to submit it. Answer, submit. That's the right answer. You're 1 gold star. Okay, so let's just comment out the debug. Okay. Does this work? Yes, we have debug here and other debug stuff. I'm gonna comment out as well. Okay. We're gonna copy it and I'm gonna just go here and paste over it. And this should be the entire query. That should work just fine. Let's just double make sure. Run. Instantly answer. Beautiful. So this file. Oh, this one we can just close. Yeah. Okay, so complete puzzle 1 of day 1. Let's push it. It's in a repo. Awesome. So let's go to part 2. All right. You're sure that's the right password, but the door won't open. You knock, but nobody answers. You build a snowman while you think. As you're rolling the snowballs for your snowman, you find another security document that must have fallen into the snow. Oh, wow. And due to newer security, a method that says all too easy. Oh yeah, that was easy. Due to newer security protocols, please use password method, whatever that is, until further notice. Well, elves went really way too far. You remember from your training seminar that method blah, blah, blah means you're actually supposed to count the number of items any click causes the dial to point at 0, regardless of whether it happens during the rotation or at the end of one. Following the same rotations as in the above example, the dial points at 0 a few extra times during its rotations. Okay, so this is going to be simple. Just the moment we have that, if it's over something, we'll just need to count the number of rotations it kind of overcorrected. Yeah. The dial starts by pointing at 50. Dial rotated 68 to point at 82. During this rotation, it points at this once, but yeah, but if we have rotation like negative 2000, oh, there we go. In this example, dial points at 0 3 times at the end of rotation, plus 3 more times during rotation. So in this example, the new password would be 6. Be careful. If the dial were pointing at 50, a single rotation like R1000 would cause the dial to point at 0 10 times before returning back to 50. Exactly. So, yeah. So we use the same data. Although it hasn't changed, you can still get your puzzle input. Okay, so let's just day 2, SurrealQL, and we can actually just grab it all, paste it here, and wow, that is a lot of lines. We'll start with empty thing. So let's adjust it, all right? We can reset everything to have it from scratch. We can run it like, we're gonna operate on our simpler input first, okay? So we need to count the times that we kind of pass it to negative or positive. So this is basically whenever we wrap the value, we need to count how many times we wrapped it. So if the value is less than 0, we counted those revolutions, right? In this case, this is how many times we actually need to wrap back to the normal. So this will be exactly what we're looking for. So adjusted values, this. So revolutions. We know that the moment we got in here into this situation, we already have 1. And therefore, this 1 revolution to the right, let me think about it. So if we were at, let's say, 50, I'll do it. Let's say we were at 20, and we did L1000, okay? That means that we did 10 full rotations. So that means we will be at negative 900, 80? Yeah, negative 980. Okay, I know that this is 10 full rotations, means 10 times at 0, okay? So in this case, revolution will be new value minus 1, so it'll be 980 divided by 100, which will be 9, and then plus 1, which will be 10, okay? And then we have that extra readjustment that I think we don't care. But what if we had the situation where we had 0 because of stuff? Let's do it in a very simple way. If we have a situation like this, we're going to do that, which is... yeah, we're going to do exactly that, I think. Because if we were to do that, being at 0 already, one full rotation, if we're already at 0, one full rotation, like negative 100, oh, that's probably what it was. Because we had that problem with those rotations not being counted correctly, because we had a situation where we started at 0, we had go left 2000. So that should be 20 full rotations, right? So that made it to negative 2000. And that means that our calculation of revolutions was 2000 by this, which is 20, and plus 1, which actually made it into 21. Because we were at 0.0, and then this extra adjustment brings us back to 20, which is the correct number. So I think we can just update our password by the number of revolutions, and then in case we were to adjust, we had this case, we just update it again, just in the other direction, and that's it. We decrease it. So I think we can do exactly that. So basically we have number of revolutions, right? So we will do the update of the password, which is this. We update it by the number of revolutions. How are we doing, Mithridates, by the way? How are things going? So this will count the revolutions, but if we had this one, we just do minus equals 1 to just walk it back, whatever. It's good enough. Okay, that should be it. But if we're going to the right, we again count the revolutions. So we just do revolutions. And if it's here, we count it because it happened to be at this value. Yeah. I think that will be correct. I think it will be correct. So let's just look at this little fun fake it input. I'm just gonna try to simulate here. So we started 50, right? We L47 will make it to 3. 50 will make it 53. This will make it to L53, so it'll be 0. So here we have 1. So we can just do plus 1. I mean, let me just do it top down. It'll be way easier. We start 50, we do 47, so it'll be 3. 50 will be 53. Now it's 0. So we have 1. Then we're gonna left 10. It'll be negative 90. Which will go to negative 90, right? Oh, sorry. Negative 10. Which will count as no revolutions. 0 revolutions. We added 1, nothing. Okay, so it will be still, won't count as the thing. Because we started from 0. Beautiful. Then we're gonna do negative 10, which will end up being 90. Okay. Then while we hit there, we're doing left 90 will be 0, which will be detected as 0, will increase 1 once. Okay, then we do right, left 2000 times. So it was negative 2000, right? We know that it was 21 revolutions. So it was, 21 revolutions, but we walk 1 back once, so it's going to be 20, so it'll end up being 21. So it'll be plus 20. Okay, and then we're going to do 99, so we're going to end up being 99. No changes. R1 will be 100, which will be walk back 1 rotation. So oh, that's right. So it's gonna end up being 0 and should be increased only once, but something tells me our code actually will count it twice. So just to make sure, what was the case here? We're at 99. We're at 0. We added 99, and then we add our 1, so it'll be 100. So we have our wrapped value. Why does it select everything? What the heck? Wrapped value, and we have if it's larger than 99. Because we just went from 99 to 100. Okay? That's the new value. So the revolutions is this 100 by 100, which is 1 revolution. And we add this revolution here. So we add it here, right? But the problem is we ended up at 0. Therefore, we're going to increase it again. So the number of revolutions that we set here needs to be always just 1 smaller. So we can probably just get away but saying, hey, updated by the number of revolutions, which in this case will be always at least 1. So we do just -1. Oh no. Gosh, this starts to hurt my brain. So what if we went to 101? Ha. There we go. This is the case where if it ended up on 0, only then remove that extra thing. Okay, so we increased it by 1, but that's the new value. So let's do, we called it adjusted value. Okay, we can use the same naming, adjusted value. And we're gonna eventually return the adjusted value. Or maybe even here can be just final, because we won't change it again. But if final value is 0, then we need to update it back, decrease it by 1, and then we can return it. Oh, it's messy. Metrodate says, just documenting a ton of stuff today. Must inundate the world with info and examples. That's awesome. You're doing awesome work. Absolutely awesome work. So in this case, when we went from our 99 to 100, right? This means revolutions will be counted as 1, and we increase it. But really, we can't, because we'll be counting it again. So the final value will be the 0. And if it's 0, then do that. Yeah. Yeah, we can do that. I think that will be correct. And that should be it, in my opinion. Let's just run it. 225. That's what it says. So let's complete our example. Okay. We went to 99 to 0. It should increase only once. Then after that, we have our 5. So it'll be up to 5. So nothing changes. And then 20,000 times. So it'll be still 5. But 20,000 is 200 rotations. So it'll be 222. Wait a moment. And what did it calculate for us? Calculate 225. Huh. Okay. Time to whip out our debug stuff and run it again. Let's see what is happening there. Go Explorer, temp, debug, 50. We have 3, nothing changed. Plus 50, 53, nothing changed. So now we have negative, it'll be down to 0, so pass is good. So if 0 minus 10 will be 90. So we went from 0, negative, it was already 0, so it shouldn't have added the value. Okay, so this is where the problem comes from. Because if we went from 0 into the left on the dial, yeah, we didn't cross anything. So let's investigate that. Okay. So our move is that we had 0 and we did minus 10, which means it's negative 10, which then is translated to 90. Okay. One rotation to right to correct it. But it was at 0. So that's the problem here. Revolutions is the new value. So the new value have wrap value. So I guess we should have a situation where if it was at 0, only then decrease the number of revolutions. Okay. So something tells me a lot of this can be simplified. And this thing, if it's 0, increase password. But if it already was at 0, then don't. Okay. Let me think about it from scratch. So we have several situations here with our dial. I'm just gonna note it here because I know it's easy to kind of do it here. Was it that there's some kind of something like this where we can? No. Oh well. So we have two situations, like to left and to right. So to left, we can go from 0 to negative like 1. Then we can go from 0 to 0, 1 plus rotations. And that's pretty much it when it comes to edge cases. Then we have from number x to 0, and from x to 0, 1 plus rotations, because we just rotate a bunch. And we have this to X. And 1 plus rotations. Gosh, there's just so many things that can go wrong. But yeah, this is definitely it. If it was already at 0, and we're gonna calculate revolutions was like 1 revolution because we did 100. That revolution counted will be already enough that we don't have to count the 0 second time. Therefore, we can avoid some extra cases here like, oh, did we end up at this? Did we do that? Okay, so in that case, to the left, let me just get rid of all this. We count the number of revolutions, and therefore, if we have, I don't know, -10, right? It will calculate it as 10 by 100, so it'll be 0 plus 1, which will be 1 revolution. That's what it's gonna count. Okay. We got the adjusted value is this revolutions times 100. Okay. But if it was already at 0, it's gonna get adjusted. And we don't want to have this special case here. Okay, because this special case here exists only because this will count it the second time. So we should be able to just get rid of this part. Okay. And this should be okay as long as we have this case here that the wrapped value is 0 and dial, because that's what we extracted earlier, right? Right, in that loop, we read the dial before we calculate a new value. So that old value of the dial is not 0. So if the old value of the dial is not 0 and the new value is, then we increase it that 1 extra time. Otherwise not, because it'll be already counted in how many revolutions did we make. So that was the case of that we checked from 0 to something like -10, right? But what if we had 10 and we went to -10? Okay, that means it will be entire revolution and it will count it, even though whatever, I mean, yeah, it will just count it as 1 revolution. If we will go from 0 to -100, okay? So this is the case where we actually went the whole thing. It will be so what's 0? We went to -100. So revolutions will be 101. So with 2 revolutions, that's what it's going to count it as. 2 revolutions. Then that adjusted value is this and that. So it will do 200. So go over to this and that. So that would actually adjust it twice. So we need kind of that decrease after all. Yeah, I think we need that after all here. because this just only did once, but we won't have one extra added at the end because it was 0. Okay, good. I think this will be good enough. I believe this one's complete. Now let's just take care of the positive so that we have taken care of a few situations. Let's say we had 10. We went to 110 or like 120, which really should be corrected to, at this point, 20. So revolutions will be 120 divided by 100, which will be 1 revolution, which is correct. We update it. Bam. And if final value is 0, then we decrease it. Otherwise, we already increased the number of revolutions. But here we have this thing. If the final value is 0, why would it decrease it? So let's run a situation, because otherwise it'll be good. It's not adjusted in the case, so it's great. But if we're gonna go to, we added 90, right? We went to 100, which is really 0. So we hit 100. That was 1 revolution, okay? And we did all that fun stuff. And here, if final value is 0, then decrease it because we didn't. So this is only because this one will increase it. Okay, great. But what if we had situations where we had 0, we added 100, okay? And I went to 0. I mean, that's 1 full revolution, right? So it'll be 1. We upgraded to 1. So 1 revolution, right? And final value is 0. So it's going to like, oh, wait. We actually removed that 1 revolution. So we had 0 revolutions. And this one here will be like, oh, we started at 0 and we ended at 0. This should have been counted in revolutions. So, ooh, no. Okay, so we have that edge case here no matter what. It's never that simple. What if we walk it back only if the dial before wasn't 0? Sure. And dial is not 0, was not 0. Then we'll walk it back. If it was 0, we don't. Because if this wasn't 0, and this, then we increase it. Ugly, but maybe it's gonna work. Reset everything. Round effect input without our shenanigans here. We know it should be 222. So we have our new query. Do I still have somewhere to comment somewhere? Yep. Oh, come on. Run the query. Now we're down to 224, so it's still problematic. What? It's already past midnight? Holy moly. After this one, I'm finishing. Okay, 50 minus here, new value is 3. We didn't cross anything, good. Up to 53, we're all good. We went to 0, we good. Then from 0, negative 10 should be to 90. Why did it increase the pass value? We didn't cross anything anymore. Come on. So I guess I need to check that before value here anyway. So the revolutions number is here. So we went from 0 to negative 10, which will lead to 90. So 10 divided 100, 0 plus 1, says 1 rotation. So we updated that. And then we calculate if the adjusted value is, yeah, that's the adjusted value. Final value is basically, if the adjusted value is 100, as in we went entire rotation, then we're gonna decrease it, whatever. Great. Awesome. So that would work for situation like from 0 to negative 100, which would be 0. That will work. That would, at this point, not change it. But if we went from 0 this sounds like just having, okay, calculate the new value and whatnot, and that's it. That doesn't really make much of a difference here. It's not a good spot to calculate those zeros. It just feels like, although in the beginning is like, okay, sure, we calculate a new value or whatnot. But besides that, we check if it's already at 0, just simply calculate how many rotations that was left to the right. And that will be like how many full rotations it was. And that will be how much the pass rate increases. Okay. And that will be it for the additions and subtractions. Otherwise, follow normal rules. Ay, ay, ay. Let me just trudge through this one. So we have the situations where we end up at 100. Doesn't mean that if I have negative 10 and I add, oh no, I can't start at negative 10. Let's say I started at 10 and I did something like negative 110. Okay, that will be basically negative 100. Negative 100 will be 100, so it'll be 1, it'll be 2 rotations. So it's gonna do 0 plus 200. Wait, what? Yeah, plus 200, and that will end up being this extra 1. And that's why it's like that. Okay. That makes sense. But yeah, and this will work because it ended up at 100. Okay, I'm getting confused. Let me just take a short bathroom break. I'll be right back, maybe with a little bit fresher mind, all right? So give me 3 minutes. All right, I'm back. Everyone else left. As always. Oh well. Okay, so I thought about it, and I think it's time to actually draw something. Do I have like some like Krita or something? Something I could draw in. Image viewer, no. Kdenlive, no. What is this? This looks like I could write in this. It's like pixelated. Oh yeah. New document. Sure, at least that resolution, please. Okay, this will be a little bit better. So we have select. Can I like draw an ellipse? I can. Okay. So we have, I'm just gonna draw a bunch of those so that we can kind of imagine different cases. Because I think we can just decouple the logic of calculating what's the end value is. Like, you know, after wrapping, what's the end value of the dial? We can completely decouple it from how many times we're actually turning things. Let's just grab a line or something, and this will be our 0 point everywhere. Okay. Top is the 0. Okay. All right. So first, can I like literally grab this, copy paste? Yes, beautiful. Okay. We have something to work with. Awesome. Now how do I deselect? Escape now. Doesn't have a menu. Deselect all. There we go. So let me grab some, oh, this color is fine enough. So let's say that we start, like this will be, we all start from 0. Start 0. Okay. Start from 0. If we're gonna go a little bit, okay, some number, like just not full rotation, we don't change it. If we go over full rotation, like negative 100, that's our move, then it will be 1 rotation. The same goes here. Not full integer value, no rotation. Full thing, 1 rotation. The same thing goes if we're gonna go 1, 2, and end up somewhere 3. It's, let's say, 340, right? Plus 340. Oh, wow, this is horrible. That'll be just plus 3 times that we pass 0. So this is very simple. No weird calculations required. Now let's say that we start from somewhere positive, right? Let's say this is 10. We started 10 already. Now, basically how many rotations we did is gonna be this plus or whatever, something like that. So let's say this is 20. So we just do 20 minus that 10. And how many full rotations are this? Plus 1. So basically the moment we detect that we went negative here, we already have 1. And then we calculate if there's anything extra, right? So in case where we started from here, we went over here and I don't know, maybe all the way to here, okay? That means we went 100 and maybe 20, right? 120, negative 120. We hit it twice, so we know this was 10, so we do negative 120 plus that 10, which will be negative 110. And from here we have negative, like entire negative rotation. So it'll be negative plus one extra negative because we crossed it the first time. We went basically to the negative. Now let's think about going from here to positive. So we start from 10 again. If we go a little bit, we didn't go to anywhere across, so we're good. Nothing happened. When we go over the 99 to somewhere here, then we already know that this is plus one rotation because we went over 99. But then past that, so let's say it was 10, so we do 100 minus 10 will be 90. While we really went full on 95, that was our amount of rotation at 95. Minus that 90, that will get us that we did only 5 extra, which is 0 for full rotations, so we stay at that. Different story would be if we start from here, and then we went on here, 1 rotation, right? And then we ended up doing 2nd rotation. And maybe even past this one. So that's when this end value will be extra 1, because passing this point, we did an extra rotation a little bit. Okay, so I can see this working. And the last thing for me to kind of brainstorm right now is if our starting point is in negative, because we're kind of use this as a reference to figure out calculations. So if we're gonna go to positive, we can't even start at negative 10. So nope, we don't have such situation because we always start at positive number somewhere here. We just have this adjustment. So really we have just those 2 cases. Yeah. 3 cases. One case is where we start at 0 and we just count full rotations, no matter if it's positive or negative. We can just use the input that we got, like, hey, rotate 90 to the left, right? We calculate it purely from there. We just make an absolute out of that. I can calculate how many rotations, and that will be our actual input. Otherwise, we have to the left and to the right situation, which are relatively similar, just slightly different calculation. So what I think we can do is, instead of dealing with all the stuff that we have here, I just grab it all, delete. We go to our original solution. Okay. We grab it and we plop it here. So this will be our start. We know that this works. This works for just counting how many times we cross the value left to right. But also, this thing is currently correctly calculating the end value of where we ended up with the dial. That means that we can remove all the things here, because where do we update the actual pass ID? Instructions, this new value, let. Nothing here. We're not setting anything here. We just update the dial, and if it's at 0, increase the password. That's all we were doing. So now we're not even doing this. We'll just end up updating the dial, right? Because that's the end value of it, or whatever. But separate from that, we'll need to basically calculate, now do something like calculate how many times we pass 0. Okay. Okay. So let's start from the first thing. If our dial is 0, because this is our situation where we start at 0. Okay? So in this case, all we care about is the input value, the instruction that we got. Go that much left, go that much right. We just divide it by 1,000, by 100, and the full numbers that we get out of that, that's the actual number of rotations. We just need to make it absolute. So I believe we can find something inside our database functions. Do we have something like math functions? Absolute. There we go. We can get an absolute value of the number. Beautiful. So in this case, if it's 0, we just take our input, which is in our loop, there will be the instruction. It's just a number, plus or minus. So it's our instruction divided by 100, and this is our rotation. So let's do let revolutions is this much, right? And then we do update. What was it? Pass ID set value plus equals revolutions. And if it's 0, this will just not update it, and that's it. Okay, great. So that's yeah, that's the entire top. Because the end value of the dial will be already calculated, so we don't care. Oh wait, we just needed to make the instruction.abs to make sure that negative positive value doesn't do anything. Good. So next is else. So otherwise, we are not starting at 0. We are already at some plus minus something. So let me think now, because something tells me we will be able to just combine it together. So let's say that we go with the positive numbers first. So looking at it with a little bit more detail, we started at 10 here. Our command was plus 15. Okay. So in this case, we didn't go over. So we would basically need to calculate what's the minimal value to go over, right? So if it's positive, yeah, so basically if we have positive, we need to calculate it one way. If it's negative, we need to calculate it the other way around. So yeah, let's do that. So otherwise, else if instruction is larger than 0, as in we're moving positive direction, then we basically need to calculate minimum or whatever flex. Let's do till 0 or distance to 100. Okay, our distance to 100 is basically 100 minus current value of the dial. Okay. So we do 100 minus dial. Okay, this is distance to 100. So now, how does it affect our thing? Because our rotation here, whenever it reaches that distance or greater, only then we actually have something of value here. Okay, I don't like it right now. Because thinking about it, it's like, okay, we got a 10, you got plus 15. Is that 15 larger than the distance? Did we get over the threshold? If yes, if it's meeting that, we already add plus 1 and then calculate from here how much more. So it'll be the plus minus the threshold, and that's the leftover that we divide. It's just like a lot of calculations for some reason. But I guess that's what we need to do. We can start with that. Where do I have it? Here. So that's the distance. So now if the instruction is larger or equal distance to 100, only then we're doing something, okay? So at this point, if it's larger, then we already can update our thing by 1, okay? Because we know that, okay, we ended up at 0 or crossed it. And then we basically need to calculate how many extra revolutions. So it'll be extra revolutions. So let extra revolutions is the instruction minus distance to 100. And this whole thing divided by 100. So how many extra full revolutions after that we did? And this is basically a number to update our thing with. So instead of doing it twice, we can just do 1 plus extra revolutions. There we go. That should be it for the case when it's larger. If it's not, we're not doing anything, right? We just, yeah, that's it. Yeah, I guess that's literally it. And now we have else if instruction is less than 0, as in we're going in the other direction. We need to probably do something very, very, very similar. So we were here, and now we have a situation where we either went from here, right, from 10. Whoa. It's hard to write with a mouse sometimes. And we went just a little bit. So we have the same thing. We just have distance to 0. And that will be a negative distance, I believe. So that will be just the inverse of the current dial. So if this was like -5, it will be nothing. So we can do something like let distance to 0 is negative dial. I'm not sure if I can do that. I'll just do times -1. Should be the same result. So that's distance to 0. And basically here we have the situation where if that instruction is less than the distance to 0, because remember, this is a negative value. If it's less or equal, okay, then we're gonna do pretty much the same calculation. Because let's say this is the case where we have that distance minus that thing. So we kind of shorten this thing, cut it here, and count how many revolutions, in this case in a negative direction, happen. So we can do basically let extra revolutions is, and we do the instruction. If you have, if you subtract a negative value, it will be positive, so it's gonna kind of negate this negative value already. So we minus distance to 0. Okay, so that's pretty much the same. And we just make sure we have a positive value divided by 100. And this will be our extra revolutions. And then we have literally the same thing here. And that should be it. Because if the instructions are 0, we didn't move anywhere, therefore nothing happened. Yeah, there we go. I think that's all we need to add. Let me reset this. Reset. Let's set our fake input. Run. And the new query. Run. 2, 2, 3. Ay. Did we miss something, or did I just miscalculate when running things by myself? So let's enable debugging, and we're going to run it again, and let's just trace for potential bug. But hey, this is like a little bit closer, right? It's progress. Oh, and we didn't close this properly. There we go. Now it should be fine. Run the query. Explorer, and we have our debug. Start 50, negative 30, minus this, so we didn't cross anything, okay? Then we added 50, we added 53, and didn't increase. 53 minus 53, we go to 0, increase by 1, beautiful. Now we have 0, negative 0 went to 90, nothing increased, great. 90 minus 90, we went to 0, this increased, correct. And now we are at 0, and we add 20 rotations. So it'll be 1 rotation, 2, 3, so that'll be plus 20, right? So that'll be 22. Perfect. Okay, that's correct. And we are still at 0. So then we add 99, so it'll be 99, we still have 22 value. Perfect. Then we go into add 1. That should increase it to 100, which will be crossing over, so we have 23 pass values, and we end up 0. Perfect. Then we hit instruction 5. It's good. And then we do 200. Oh yeah, so it is supposed to be 223. So this is correct. Okay, wow, first time. All we needed to do is write some circles and arrows, and and we have something way more readable. Where's our code? So this goes away. Go to our query. Let's disable the debug stuff, and that'll be it. Bam, bam. So I'm just gonna copy that code here into day 2. Okay. And let's clear our sandbox. Let's use the real input. And now run the query. And the result is 6,738. Submit. That's the right answer. Okay, awesome. We completed day 1. So I know the live stream was showing day 1 and 2, and I was confused. Didn't know that it's 2 puzzles a day. So yeah, we just completed day 1. So tomorrow we're gonna complete the day 2, right? Because we completed this. Great. Oh, we have day 2. Oh, I see. So each start for each one. Whew. Okay, it's nearly 1 a.m. on my end. So I'm gonna rename this live stream to be just day 1. And tomorrow we're gonna try to catch up. I think we're gonna move a little bit faster. I got back to speed with SurrealDB. But as you can see, we can do pretty fun things. Let me just grab this code and say complete puzzle 2 of day 1. All right. Again, code to the repos in the description. This should work. So yeah, this is fun. Using a database to calculate this stuff. I mean, it's just like programming, right? Just a little bit more clunky, but with superpowers of having a database verify stuff for you. Yeah, fun. All right. Thank you everyone for watching. Thank you for hanging out with me, Mr. Dates. It was fun, and I'll schedule the one for tomorrow as soon as I can. See you.